Alright guys, I posted a copy of these notes. Today we're going to talk about the division of complex numbers when the denominator is a monomial. So once again, we're going to do some work with radicals, and we'll do some work with imaginary terms. There we go. So the thing about radicals and imaginary terms is that we can't have a radical in the denominator, nor can we have an imaginary term in the denominator. Remember, I is the square root of -1. So technically, this is the square root of -5 in the denominator, which is why we're doing these together, because really it's kind of the same thing. That's the square root of 5, that's the square root of -5. So since they're kind of the same problem, it's going to have the same process. Now the process that we want to follow is that we want to get this square root to go away. So the way that we're going to do that is that we are going to multiply this square root by something so that it becomes a perfect square. And then the square root of a perfect square is just a regular natural number. So since I had the square root of 5, I decided to multiply by the square root of 5, because 5 times 5 is 25. There's my perfect square. And then since this is not an equation, it's just an expression. So whatever I do to the denominator, I have to do the numerator because I can only multiply by the ratio of 1. So over here, I showed my setup to distribute. And 3 times the square root of 5 is 3 root 5. Square root of 2 times the square root of 5 is the square root of 10. And then the square root of 25 is 5. I take a look at my radicands. Neither one has a perfect square factor that could come out of that radical symbol. So 3 root 5 plus root 10 all over 5 is my final answer. Notice how I am not simplifying the 10 and the 5 or the 5 and the 5 because I cannot simplify them. The square root of 5 is something a little bit bigger than the square root of 4. The square root of 4 is 2. So that means that this right here is like 2.1. 2.1 and 5 can't reduce. The square root of 10 is a little bit bigger than the square root of 9. Square root of 9 is 3. So this, let's say 3.1 and 5 cannot reduce. So even though I see the 5 and the 5 and I see the 10 and the 5, they cannot reduce because the square root of 5 and 5 do not simplify. Now over with imaginary. I had 5i in my denominator. I need to get rid of the I. Now in our previous sections, we decided that I times I is I squared. I squared we know to equal -1. So as a result, if I can get this I to become I squared, I can then rewrite the I squared as times -1, and 5 times -1 will give me that -5. Again, it's an expression, so I have to multiply by the ratio of 1. So I distribute the I to both terms. I times 3 is 3i. I times 2i is 2i squared, and then 5i times I gives me 5i squared. And now I'm just going to simplify because I squared is -1, so I have 3i, and then this was plus 2 times -1, or -2, and this was 5 times -1, or -5. Now I also said that we need to make sure the imaginary term and the radicals come second. So I'm going to move this -2 in front. So I get -2 plus 3i all over -5. Now I'm okay with this answer, but some teachers believe that the denominator should always be positive. That is technically the most simplified version. So again, I'm going to kind of do this step and multiply by -1 over -1. And it switches all the signs. So 2 minus 3i over 5 is the same thing as this ratio, which is the simplified version of that. So I posted 2 problems. The first one is simplifying a radical. The second one is simplifying an imaginary term. They're posted in the assignment. Try them out, see how it goes. Let me know if you have any questions. Good luck.